Right, looking at finding the nth term of a linear sequence. First of all, a linear sequence would look something like 3n plus 5. It would not have an n squared in it. It would also show you a constant, what's called first difference. So for example, this one here, that difference there is plus 4, that's plus 4, and that is also plus 4. That's classed as our first difference, and that would indicate we've got a linear sequence. Okay, let's look at finding the nth term. So starting this question again, 3 is the first term in the sequence, 7 is the second term, 11 is the third term, and 15 is the fourth term. We are looking to find what is called the nth term. So I would suggest you write the 0 term. So whatever value we get there for position 0, that will help us calculate the nth term. So our step 1 here is very simple. First of all, find the first difference between each term. We did that a second ago, and we found the first difference was plus 4. Now, once you've found the first difference, you have found the first part of the nth term. That constant 4 shows us we're going to have 4 lots of n in our term. To find the bit that bolts on the end, we find the sequence value at position 0. To do that, rather than adding 4, because we're going this way, we take it in reverse, and we subtract 4 from the 3, which gives us minus 1. It is that minus 1 that bolts on the end of this expression. So now we have found our nth term is equal to 4n minus 1. So a quick recap of the steps. Step 1, write in position 0. Step 2, find the first difference. Write out the first part of the nth term. Step 3, find the sequence value at position 0. Step 4 is bolt that onto the end of the expression, and that is your nth term. So let's go through this second question. The difference between each term is minus 2. That tells us we have minus 2n in the expression. Let's find position 0. So we go backwards by adding 2. We're doing the opposite. We can see the sequence value at position 0 is 22. It's a plus 22 or a positive 22. We bolt that onto the end of this, and therefore the nth term is equal to 22 minus 2n. So it's a bit neater to switch those two around. You don't have to, it's still correct this way, but this will help you ensure that negative sign doesn't get lost. Same thing here, find the first difference, write out the first part of the nth term, go back and find the 0 position, bolt the sequence value for the 0 position on the end of that expression, and that is your nth term. There's not much more to find in the nth term of a linear sequence than that. Let's have a look at a couple of different questions. So in question 4 and 5, we're asked to find the 11th term of the sequence. So we're not writing down the first 5 terms, we're looking for the 11th term. Well, this is pure substitution, so n is equal to 11. So in this case, we have got 50 minus 3 multiplied by 11. That is 50 minus 33, and that just gives us 17. So the value of the 11th term is 17. Same here. We've got 4 n's, we've got 4 times 11, and we're taking away 10. Well, that is 44 minus 10. That gives us 34. So the value of the 11th term is 34. Our final question is, if the nth term of a sequence is 2n minus 1, is 35 part of that sequence? The key thing here to recognise is, does 2n minus 1 equal 35 where n is an integer, a whole number? So really what you need to do now is solve this, and if n turns out to be a whole number, an integer, 35 is part of that sequence. If n does not turn out to be an integer, it is not part of that sequence, because you're looking for a position, 1, 2, 3, 4, 5, that kind of thing. You're not looking for position 1.5 or 1.7. So all we do now is we solve this for n. So I've rewritten that over here. First thing we need to do is get rid of this minus 1 by doing the inverse. So we're going to add 1 to both sides of the equation. That becomes 0. We are left with 2n equals 36. Again, we're trying to get n on its own, so we need to get rid of that 2. To get rid of the 2, we divide both sides by 2. Remember, balancing the equation. 2 divided by 2 is 1, so now we're left with 1n. So therefore, n is 36 over 2, which is 18. So now we can answer the question that 35 is part of that sequence because n is an integer. So 35 is the 18th term. So that's it for linear sequences. Again, if you got something out of this, please like and subscribe. If you found that straightforward, hop on to the next video and have a look at finding the nth term of a quadratic sequence.